This is 1.4, question number 1 for chapter 1. Without actually performing the long division, without dividing the numbers, state whether the following rational numbers. Okay, now the question is, all the numbers given are rational numbers. Rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. Remember, terminating decimal means rational number. Non-terminating but repeating decimal expansion, also a rational number. The one which is not a rational number is non-terminating decimal, non-terminating, non-repeating. Non-terminating, non-repeating means an irrational number. Okay, remember this: terminating decimal and non-terminating repeating decimal are rational numbers. Non-terminating, non-repeating are irrational numbers. Okay, so the first one, 13 by 3125. So we have to find out whether 13 divided by 3125 is a terminating or non-terminating decimal. So here, 3125. 5, 6, you get 30, then 12, 5, 2, 10, 25, 5, 5, 25. 5, 1, 5, 12, 5, 2, 10, 25, 5, 5, 25. 5, 1, 5, 2, 10, 25, 5, 5, 25. So 5 into 5, 25. So how many 5s are there? 1, 2, 3, 4, 5. So 5, 5. So 5 to the power 5. So equal 13 by 5 to the power 5. So here, the denominator, this one, denominator Q equal 5 to the power 5 equal 20 to the power 0 into 5 to the power 5. This is of the form 2m into 5n. M and n are integers, non-negative integers. So we should remember that any number, if you divide any number by 2 or by 5 or by both, the number will always be a terminating decimal. Okay, so in the denominator there should be 2 or 5 or both. Then the number will be terminating decimal. Okay, if there is other factors like 3 or 7 or any other factor other than 2 and 5, it becomes a non-terminating decimal. So here there's only 2 and 5. There are only 5, so 2 is to the power 0, becomes 1. So fine. So 5 to the power 5. So this is the form 2m into 5n. Okay, so that's why it is a 13 by 3125 is a terminating decimal expansion. Okay, let us prove whether this is a terminating decimal expansion or not. Okay, in the exam this is the end. Okay, this is just for your understanding. In the exam you write until here and that is more than enough. This is for your understanding, okay, to practice. Now 3125 you divide 13. Okay, so 13 is only 2. There's you have 4, so you go with first 0, you get 0 here, bring down 13. Okay, so you add a decimal point here and then you get here 0. 1 decimal point 1 0. Okay, so this becomes 130, 130, but this is 3000, so still small. So you get add another 0 here, you get 0 here. Okay, so it becomes 1300. 1300 is just smaller than 3000. So you add another 0 here, you get here another 0. So it becomes 13,000. Remember, 2 zeros and 1 decimal point. So here 3 zeros. Okay, 1 decimal point 1 0, 1 0, 1 0, another 0, another 0. 2 zeros and 1 decimal point. So here 3 0. Okay, this is just to write in the beginning. Okay, beginning of a decimal point. So this is 3000 and this is 13,000. So 3,000 into 3 you get 9. Okay, 9,000. 3,000 into 4 you get 12,000. 3,000 into 5 you get 15,000. Okay, so we'll go with 4. 4 5 20, carry 1, carry 2. 4 2 8 plus 2 10. 4 1 carry 1. 4 1 4 plus 1 5. 4 3 12. So 0 minus 0 is 0, 0 minus 0 is 0, 10 minus 5 is 5, this is 2, 2, 0, this is 1, 1, 0, okay. So the remainder is 500, and then add another 0, becomes 5,000. 3,000 into 2, you get 6,000, so go with 1. 3 into 1, you get 3, 1, 2, 5. 10 minus 5 is 5, 9 minus 2 is 7, and then 9 minus 1 is 8, and then here becomes 4. 4 minus 3 is 1. So 1875, and then add another 0. So this is 18,000, nearly 19,000. So this is 3,000. Okay. So 3 into 6, you get 18. 3 into 7, you get 21. So we'll go with 6. Okay. 6, 5, 30, carry 3. 6, 2, 12, plus 3, 15, carry 1. 6, 1, 6 plus 1, 7. 6, 3, 18. Okay. So the remainder here is 0. Okay, so remainder here is 0. Okay, so this is 18750, and this is 18750. So remainder here is 0. So we have proved that 13 divided by 3125, this is the answer. It terminates, it ends in 6. So it is a terminating decimal. Okay, so this is a terminating decimal. This is number 2, 17 by 8. Here 17 by 8 equals 17, because 17 is a prime number, so it will stay as is. Okay, and 8, what is 8? 8 is 2 cube, simple, isn't it? 2 into 2, 4, 4, 2, 8. So now here the denominator is 2, isn't it? Only 2 exists. 2 cube, only 2. Okay. When you consider whether it is terminating decimal or not, you consider only the denominator. Okay, the numerator can be any number, it doesn't matter. You consider only the denominator. So q equal 2 cube. Okay, so equal 2 cube, there's no 5, so okay, you write here 5 to the power 0, which means 1. 5 to the power 0 means 1. Anything to the power 0 is 1. Okay, so any number 1 to infinity. Okay. So which is of the form 2m into 5n. Okay, this is of the form 2m into 5n, where m and n are non-negative integers. So 17 by 8 has a terminating decimal expansion. Okay. So because it has 2, okay, 2 or 5 or both terminating decimal expansion. Third one, 64 by 455. So what is the 64? 236, isn't it? 224. We have to find factors first. 2, 16, 32, 2, 8, 16, 2, 4, 8, 2, 2, 4. So we cannot cancel, isn't it? There's only 2 here, there's no 2, you cannot cancel anything. So 2 to the power 6. And 255, 5 into 5, you get 25, 515. Since it ends with 5, remember, begin with 5 first. Begin dividing with 5 first, because it ends with 5. 5, 5, 25, 5, 1, 5, 3, 1, 3, 21, 37, 21. So you get the factors of 255 to be 5, 13, 3 and 17. But you cannot cancel anything, isn't it? Because there's no 2, there's no 3 here, so you cannot cancel anything. So that would be it. So here the denominator has 5 and then 3 and 17. Okay, it has 3 and 17. Since it has 3 and 17, that's why this is not a non-terminating decimal, because there's 3 and 17, there's other factors other than 5. Okay, so 5, 3, 17. So this denominator has 5, 3, 17 and contains factors 3 and 17. This is not of the form 2m into 5n. Hence 64 by 455 has a non-terminating repeating decimal expansion. Okay, if you divide 64 by 455, you will get a non-terminating, it will never end, but the decimal expansion will repeat. Okay, after a few numbers it will repeat forever. So it is a non-terminating repeating decimal expansion, which is a rational number. Okay, number 3. So this is 4. So 15 by 1600. 15 is 3 into 5. Okay. 15 is 3 into 5. So 2 8 is 16. 2 0 0 2 0 0. 2 4 8 0 0. Okay. 2 2 4. Then 200. 2 200 you got 200. 2 50 you got 100. 2 2 4. Then 10 to 5 10. 5 5 25. So here is 3 into 5 into 2 power 6 into 5 square. You can cancel here actually, isn't it? 3 into 5. So 2 to the power 6 into 5 into 5. So 5 5 cancel. You get 3 by 2 6 into 5. Okay. So if you cancel or not, the denominator will have 2 and 5. Okay. Because if you don't, even if you don't cancel, the denominator will have 2 and 5. This also 2 and 5. So it will be a terminating decimal expansion. So here denominator equal 2 6 into 5 to the power 5 square, sorry, or into 5. Okay, into 5 5 1, can say 5 1 here, okay, because only 1 5, which is out of form 2m into 5n. Okay, where m and n are non-negative integers. Hence 15 by 1600 has a terminating decimal expansion. Okay. So number 5 2 is the same. 29 by 343. 29 is a prime number. So see what it says. 343 is 7 cube. It cannot be divided by any number but by 7. 7 4 28 by 9 63. 7 7 49. So 7 cube. 7, there's no 2, there's no 5 here. So it is a not of the form 2n into 5n. So this 29 by 343, it has a non-terminating repeating decimal expansion. Okay, because there's no 2 here, there's no 5 here, and 29 is a prime number, so don't care about the numerator, only the denominator. It has 7, no 2, no 5. So even if it has 2 or 5, because of the existence of 7, it will still be a non-terminating repeating decimal expansion. Okay, so that is number 5. This is number 6. 23 by 2 cube 5 square. This already, this is not 2 cube. Okay, this is 23. Sorry, this is 23. Okay, not 2 cube. So 23 by 2 cube 5 square. So denominator here is 2 cube and 5 square. This is also the form 2m into 5n. Okay, 7. So m and n are non-negative integers. Hence 23 by 2 cube 5 square has a terminating decimal expansion because it has 2 and 5. Simple. Number 7. 129 by 2 square 5 to the power 7 and 7 to the power 5. This is a non-terminating. Why? Because of the existence of 7. Okay. Denominator is 2 square 5 7 7 5, which is not of the form 2m into 5n and has factor 7 because of the existence of 7. Therefore, this number 129 by 2 square 5 7 7 5 has a non-terminating repeating decimal expansion. Okay. Simple. Because of the existence of 7, it is not a terminating decimal. This is number 8. 6 by 15. Here 6 by 15 equal 2 into 3 and 15 is 5 into 3, isn't it? So 3 3 and cancel. Actually, if you don't cancel, then 5 and 3 it becomes non-terminating, isn't it? But you can cancel this. 3 and 3 can cancel, so it becomes 2 by 5. So here denominator q equal 5, which is of the form 2m into 5n, where m and n are non-negative integers. Okay. This also 5 to the power 1 into 2 to the power 0. Okay, you can write this, which is of the form, and where m and non-negative integers. So this is a terminating decimal expansion. Remember, if you can cancel first, cancel and then calculate. Okay, cancel the numbers that you can. 35, number 9. 35 by 50. 35 is 5 into 7. Okay, and 50 is 2 2 4 to 5 10 5 5. So 2 into 5 square. This also you can cancel, isn't it? 1 5 and 1 square, so it becomes 7 by 2 into 5. Okay, So this is power 1. Okay, so 2 to the power 2 into 5 to the power 1. 2 to the power 1 into 5 power 1. Okay, you can also write just 2 into power 5. That's more enough. This is the form 2m into 5n, where m and n are non-negative integers. Hence 35 by 50 has a terminating decimal expansion. With this we completed number 1. Okay, simple this. If you like my video, please subscribe and support my channel.